Hi, this is Alex from devstories.eu. Databricks, episode 3 of 15. The easiest way to burn through your cloud budget is leaving a massive server running empty all weekend. You want processing power exactly when you need it and zero billing when you do not. This is exactly what we cover today in navigating the workspace and compute. Your entry point into Databricks is the workspace. Think of the workspace as the unified environment where your team organizes all their Databricks assets. It provides a web interface to manage your notebooks, data objects, machine learning experiments, and the underlying computational resources. The workspace brings all your collaborative tools into one organized view, ensuring different teams can interact with the same underlying data without stepping on each other. Under the hood, Databricks relies on a decoupled architecture. Your data lives persistently in cloud object storage, while the compute power used to process that data is spun up completely separately. This separation of concerns dictates your billing. Because compute is isolated from storage, you only provision and pay for server instances when you are actively running code. When the work is done, the compute shuts down, but your data remains safely stored and accessible. To manage this processing power, Databricks offers different types of compute resources tailored to specific workflows. The first is an all-purpose cluster. You use this for interactive, ad hoc work. Say a data analyst needs a highly capable environment to query 1 billion rows on a Tuesday afternoon. They spin up an all-purpose cluster, attach their notebook, and start exploring. To prevent weekend billing surprises, these clusters rely on auto-termination. If the analyst goes home at 5 and leaves the notebook open, the cluster monitors itself for inactivity and automatically shuts down after a specified time limit. Here's a key insight regarding automation. A frequent mistake teams make is scheduling automated production pipelines to run on these interactive all-purpose clusters. Avoid doing this. All-purpose clusters carry a higher usage cost, and running multiple different workflows on a shared interactive cluster can introduce library conflicts or resource contention. Instead, production pipelines should use job clusters. A job cluster is entirely ephemeral. When an automated pipeline is triggered, the Databricks job scheduler provisions a dedicated job cluster strictly for that workload. It runs the code, and the absolute second the job finishes, the cluster terminates itself. This guarantees strict resource isolation for your pipeline and ensures you pay the lowest possible compute rate for automated tasks. Finally, if your workload is purely analytical, you can use a SQL warehouse. This is a compute resource optimized specifically for running SQL commands and dashboard queries. If you use serverless SQL warehouses, Databricks manages the underlying compute automatically. It scales up instantly when a surge of queries hits and scales back down when the queue empties out, entirely removing the need to configure infrastructure yourself. Matching the right compute type to the exact nature of your task is the single most effective way to guarantee your cloud infrastructure remains powerful during peak hours and highly cost-efficient when the work is done. That's all for this one. Thanks for listening and keep building.